Make sure it does it. Okay. So today we are learning, if you could pull it up please from Google Classroom. We are learning about two different types of triangles. Yesterday we did the Pythagorean theorem, it was right triangle. Today's triangles are also both right triangles. So I'm gonna do one triangle that is an isosceles triangle. And since it's an isosceles triangle, I know that I've got two sides that are congruent.
Are you trying to show the board?
Oh, you guys can see my desk? You guys don't want to stare at my desk the entire lesson? What? Why not? It's beautiful. Look at the grainy wood. Sorry. Here's what I've done since you didn't see. I traced this triangle. I have an isosceles triangle. Two of the sides are the same. So that means that if they're the same, I can give them the same value, x.
I'm trying to find it.
I've never read it.
Oh, okay, I've done it.
All right, so if I did the Pythagorean theorem, it would be x rad 2, okay? So I have a triangle that looks perfect, easy. What if I switch it around on you and I make it look like this? And I only give you those two little congruent signs. Would you recognize this as 45, 45, 90? Isosceles, right? And here I'm going to give you a value. I'm going to say, dun, 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 one of the sides is 8. Can you tell me the other sides? Use this info here. So think about it. One of the sides is 8. The isosceles are both going to call x. They're the same distance. And this is whatever x is times radical 2. So what is it? Go ahead. So 8. This is also going to be 8. And my hypotenuse is going to be 8 rad 2. You need to leave it in square root. We do not do decimals here. No decimals. Okay. One more. I'm going to go backwards. If this is all you were given, and I said, this is 3, what are you going to do? Someone on Zoom, tell me.
The other side is 3. And
The other side is 3, that's a leg. Another person. What's my hypotenuse?
3 rad 2.
3 rad 2, good job. All right, so you seem to got the hang of this. Now I'm gonna scroll down, we're gonna do A, B, C. Easiest 1, 2, 3. Do you guys like singing songs? I do. You guys have the coolest math teacher ever because she'll just sing a song, act like a major dork, and not even care. As long as I make you smile, my heart is full. You guys, I hope you're laughing at me right now. Okay, I put a little cheat sheet over here. I want you to look at it. This is for 45, 45, 90 triangles. It's an isosceles triangle. The two same sides are both called x. The hypotenuse is x times rad 2. X rad 2. Okay? X and x rad 2. Now, I'm going to not care that this says y or any other variable. I'm going to label them x. And I'm going to say that this is x rad 2, right? So, how do I do this? If this is x and x rad 2, I'm told that this side, this hypotenuse is 6. That means that x rad 2 is 6. X rad 2 is worth 6. They're the same. But I don't know what x is. I do think it's really important that you notice this. I'm going to make these all the same color because I want you to realize that those blue x's are the same number. The hypotenuse just has a radical 2 multiplied because it's longer. So, if 6 is x rad 2, I am going to write that equation, that x rad 2 is 6. How do I solve for this? How do I get x alone?
You can have a x to this 2x into the second power on both sides, pretty much. That's what
You know what? A lot of times I would do that, but in this case, there's an easier method. It takes less time, I'll say.
Divide on both sides.
Divide. I'm going to divide rad 2 on both sides. 6 divided by radical 2. And guess what? I cannot have a radical 2 in the denominator. This is something you have learned before. We may not have a radical sign in the denominator. In order for me to get rid of the radical sign, I have to do something called rationalizing the denominator. So, rationalizing the denominator means I multiply by the denominator, and whatever I do to the bottom, I have to do to the top. So, 6 rad 2 divided by, what's rad 2 times rad 2?
Rad 4.
Rad 4. Can I do any simplifying here?
Yes.
Stop helping, I need more people. Thank you, Rena, and thank you, Hannah. I need more people now, other people to volunteer.
Three rad 2 over 2.
So close. Check this out. 6 rad 2 over 2, because radical 4 is 2. And then, I like that 3 you said. 6 divided by 2. They're on the exterior. They're not under a radical sign. So I'm going to say 3 radical 2. That is the value of my x, which means that my 2 legs are 3 radical 2. So I've got a leg that's 3 rad 2, another leg that's 3 rad 2, because it's isosceles, they're the same size. And my hypotenuse is 6. B, x rad 2. What do I do?
You would put x rad 2 equals 16.
I do. Do the whole process. Get the x alone. Sorry, this mask is driving, hold on. Driving me up the wall. I have 3 masks in my classroom. So maybe this one of them like scratches my nose because it's all fuzzy. Ooh, this is like really hurts my ears. You guys are worth it. Don't worry. Oh, I hate masks. I'm going to go on the record. I hate this all. Like, I'm ready. Done. X equals, I divided by rad 2 on both sides. 16 divided by rad 2. Rationalize the denominator. Multiply straight across. 16 rad 2 over rad 4. 16 rad 2 over 2. Since these are on the exterior, A rad 2. My legs are A rad 2.
And you can check your work by doing the Pythagorean theorem.
Yeah, if you wanted to do the Pythagorean theorem, this squared plus this squared equals 16 squared. Absolutely, it would work. Yep. All right, I'm really running out of space. Maybe I'll do this one in blue so that 9 is my hypotenuse. So 9 equals, man, I'm sorry that there's like hardly any space. 9 equals x rad 2. I just like fast forwarded 5 steps, but that's the answer. I didn't want to do it all messy and make all those steps because that would just be too much. Too much. No, we don't want decimals. No, no decimals. Okay, so we're done talking about 45, 90s. Now we're going to talk about the next type of right triangle. Leave your answer in square root format this whole time. Okay. There's another type of triangle that we're going to talk about. It has a 90-degree angle. I'm going to make it a little bit bigger than your example. One of the angles is 30 degrees. The other one is 60 degrees. Okay, here we go. The smallest side is opposite the smallest degree. I'm going to call that side X. We're going to base all the others off the smallest side. The small side of a 30, 60, 90 triangle is opposite the 30 degrees and it's called X. The medium length side is opposite the 60 degrees and it's called X rad 3. Opposite the 60 degrees. X radical 3, not rad 2 like last time. This is radical 3. The third longest side is opposite the 90 degrees, and that is double X, double whatever this one is. So here's what we got. X rad 3, 2x. All right. If I were to change it, notice how the 30 degrees on top here, the 60s here. What if I did this? Oh, could you handle it? What if I changed the position of the triangle and it like flip-flopped on its side? Opposite the 30 degrees is my X. Opposite the 30 degrees is my X. Opposite the 60 degrees, the middle side is X times radical 3. This number times radical 3. The side opposite my 90, my longest side, is double X. They're all related together. Let me give you a sample. Ready? I'm gonna do it upside down because if you can't do sideways, upside down triangles, then you're really not grasping the whole concept. Oh, that looks like a 45, 45. Hold on, I can't. No. There you go. Here's what I'm gonna give you. I'm gonna say the side opposite 30 is 15, really long. Maybe this is like 15 centimeters. Okay. Tell me the other two sides. New people.
The hypotenuse is 30.
The hypotenuse, because this is X, this is 2X, the hypotenuse is 30. Someone new. Tell me what's opposite 60.
rad 3.
Good job. They're all related. 15, double 15, 15 rad 3. They're all related. I'm going to scroll down to ABC. I have a change to make on triangle B. So if you could please. All right. So please on B, make this an 8 and cross out the 9. I want to make sure that we're just doing X, 2X, and X rad 3. I don't want to talk about Y or another variable. So opposite the 30 is X. Opposite the 60 is X rad 3. Opposite the 90 is 2X. All right. Students today have struggled with this one, so let's make sure that we're like, good. If my value of X rad 3 is 5 rad 3, okay. If my value of X rad 3 is 5 rad 3, X rad 3 is 5 rad 3. What's X? Show me with your hand. Class, if X rad 3 is 5 rad 3, what's X? No one? New people. Hey, if this takes forever, this takes forever. Get it? So come on, help me out here. 5. X is 5. That means that this one is 5. Because look, 2X is 10. Good, good, good. All right, B. Opposite my 30 degrees, just please label it X. Forget about that Y, just put an X over it. Opposite 60 is X rad 3. Opposite 90 is 2X. So if 2X equals 8, what's X?
4.
4. If X equals 4, what's X rad 3?
4 rad 3.
Way to go, people. You're the best. Love it. And of course, here I am with this like smushed up triangle over here. Opposite 30 is X. Opposite 90 is 2X. Opposite 60 is X rad 3. 15 equals X rad 3. The side opposite 60 degrees is 15. 15 has the same length as X rad 3, which means they are the same. 15 equals X rad 3. 15 equals X rad 3. Solve it like we have before. Get the X isolated, solve for X. Divide by rad 3. Rationalize the denominator. (15 rad 3 over 3 equals X. All right. Simplify always when you can. My X, the side opposite the 30 degrees is 5 rad 3. The side opposite 30 degrees is 5 rad 3. This is 15. The side opposite 30 is 5 rad 3. That's X. What's double X?
10 rad 3?
Yay! 10 rad 3 is my hypotenuse. I'm going to stop recording, but I want to do homework problems with you.